This slide and the next few slides discuss non-overlapping contexts. Apply a non-overlapping context to statements that should be started, or stopped, at certain times or under certain conditions. The syntax is: the create context keywords, then the context name, then the start keyword, then the start condition, then the end keyword, then the end condition. The start condition defines the condition for starting. When stopped, the start condition tells the runtime when to start the statements that apply the context. The end condition defines the condition for stopping. When started, the end condition tells the runtime when to stop the statements that apply the context. There is a choice of different types of conditions for the start condition and the end condition. When a statement is currently stopped, the runtime does not process any kind of event or time for the statement. When a statement is currently stopped, the runtime does not allocate, keep or collect any kind of state for stopped statements. There is no aggregation state, pattern state, data window state or other state for the stopped statement. When starting a statement, the runtime starts anew, without existing state. When the statement is currently started, the runtime processes events and time for the statement. When the statement is currently started, the runtime allocates, keeps and collects state as specified by the statement. When stopping a statement, the runtime discards all state. The start condition and the end condition can be any of the following. The start condition and end condition can be an event type name and optionally filter conditions and the as keyword. The syntax is: the start, or the end, keyword, then the event type name, then, optionally, filter conditions, then, optionally the as keyword and a name. For instance, start withdrawal, parenthesis, amount greater 400, as W. The start condition and end condition can be a pattern. The syntax is: the start, or the end, keyword, then the pattern keyword, then, in square brackets, the pattern, then, optionally the as keyword and a name. For instance, end pattern, square brackets, login, parenthesis, user ID equals quotes U1, or page hit, parenthesis, user ID equals quotes U1, as P. The start condition and end condition can be a crontab. Crontab is a standard scheduling expression. The syntax is: the start, or the end, keyword, then, parenthesis, then, minutes, comma hours, comma days of month, comma days of week. For instance, start, parenthesis, 0, comma 9, comma star, comma star, comma star. The start condition and end condition can be a time period. The syntax is: the start, or the end, keyword, then, the after, keyword, then, a time period expression. For instance, end, after 15 minutes. The start condition can be a start at now, for immediate start. The event types for the examples in this section are: create schema login, parenthesis, user ID string, create schema logout, parenthesis, user ID string, create schema page hit, parenthesis, user ID string, comma, URL string. The below defines a context that has a start condition and an end condition that trigger when an event arrives. The first statement defines a context that starts when a login event arrives and that ends when a logout event arrives, for a given user. Create context user session. Start login. Parenthesis. User ID equals quotes U1. End logout. Parenthesis. User ID equals quotes U1. The second statement outputs a count every time a page hit event for the user arrives, between a login event and a logout event. Context user session. Select count star. From page hit. Parenthesis. User ID equals quotes U1. Upon deployment, the statement is currently stopped. When a login event arrives, the statement starts counting at 0 and starts outputting a count each time a page hit event arrives for the user. When a logout event arrives, the statement stops, the count discards, and the statement stops looking for page hit events for the user. This example defines a context that has at now for the start condition and an event type for the end condition. The first statement defines the event type that resets the count. Create schema reset count. The empty parentheses are for an event type without properties. The second statement defines a context that starts immediately and ends when a reset count event arrives, and then restarts immediately. Create context resetting context. Start it now. End reset count. The third statement outputs a count for each page hit event, resetting the count when a reset count event comes in. Context resetting context. Select count star. From page hit. Upon deployment, the statement starts, since the context has at now. When a page hit event comes in, it outputs the current count. When a reset count event arrives, the statement stops, discarding the old count. And, the statement starts again, allocating a new count, effectively resetting the count. The statement doesn't stay stopped. The output last when terminated. Keywords can be added to statements when output is desired only when the statement stops. Without these keywords, the output occurs according to the from clause. The keywords are part of the output clause which controls output rate limiting, see EPL section of the training. For instance, the first statement defines a context that starts every minute and ends after 1 minute. The start condition is a cron tab. Create context every minute for 1 minute. Start. Parenthesis. Star comma star comma star comma star comma star. End. After 1 minute. The second statement outputs the count of events, at the end of the minute only, as a single output row. Context every minute for 1 minute. Select count star. From page hit. Parenthesis. User ID equals quotes U1. Output last when terminated. This slide and the next few slides discuss overlapping contexts. Apply an overlapping context for statements that should be repeated. We use the term partition to mean a repetition. The syntax is the create context keywords, then the context name, then the initiated keyword and, optionally, the by keyword, then, optionally, the distinct keyword in parenthesis and distinct value expressions, then, the initiating condition, then, optionally, the terminated keyword and the by keyword, then, the terminating condition. The optional, distinct keyword makes each partition unique by the values returned by the distinct value expressions. The initiating condition is required and defines the condition for allocating a new partition. The initiating condition can provide parameters to the new partition. The optional terminating condition defines the condition for terminating any number of existing partitions. The terminating condition can use properties of the initiating condition. The choice of initiating and terminating conditions is the same as for conditions of non-overlapping contexts, see earlier slide. When a partition gets allocated, the runtime processes events and time for the partition. When a partition gets allocated, the runtime allocates, keeps and collects state, as specified by the statement, for that partition. When a partition terminates, the runtime stops processing any kind of event or time for the partition. When a partition terminates, the runtime discards the partition and any state of the partition. Each partition is independent of other partitions. Any given event or time can apply to none, any or all partitions. For non-overlapping contexts, you must specify the filter conditions to match incoming events to partitions. This example tracks overlapping intervals. The first statement defines a context that repeats every minute and lasts for 5 minutes each. Create context every minute running 5 minutes. Initiated by parenthesis star comma star comma star comma star comma star. Terminated after 5 minutes. The second statement outputs the count of page hit events at the end of each 5-minute interval. Context every minute running 5 minutes. Select count star from page hit. Output last when terminated. Assume the runtime current time is 2:59 and 30 seconds when deploying the above. At exactly 3, the context allocates a partition that counts from exactly 3 to 3:05 and 0 seconds and that outputs the total at 3:05 and 0 seconds, see partition P0 below. At 3:01 and 0 seconds, the context allocates a partition that counts from 3:01 and 0 seconds to 3:06 and 0 seconds and that outputs the total at 3:06 and 0 seconds, see partition P1 below. And so on. All types of contexts provide context properties. Context properties can be used in any expression. The syntax is the context keyword, then a dot, then the context property name. Use the dot syntax to access properties or methods of the context property. The as keyword assigns a name to the event or pattern. Let's say we have a non-overlapping context, for example. Create context CTX. Start login as LE. The context property name is LE and context.le.userID returns the user ID. An example for an overlapping context and a pattern is create context CTX. Initiated by pattern square brackets every LE equals login parenthesis user ID equals quotes U1 as P. The context property name is P. The pattern tag of the login event within the pattern is LE. And context.p.le.userID returns the user ID. This example demonstrates how to use context properties. And it demonstrates a terminating condition that uses properties of the initiating event. The first statement defines a context that initiates when a login event arrives for a user, ignoring duplicate login events for the user. A partition terminates when a logout event arrives for the same user as the login event. Create context user session. Initiated by distinct parenthesis user ID login as login. Terminated by logout parenthesis user ID equals login.user ID. The second statement outputs a count every time a page hit event for the user arrives, between a login event and a logout event. Context user session. Select user ID, comma, count star. From page hit. Parenthesis. User ID equals context.login.user ID. The next two slides explain the example in detail. When a login event arrives for a user, if the context doesn't currently have a partition for that user, based on user ID, the runtime allocates a partition and starts counting for that user. When a login event arrives for a user, if the context already has a partition for that user, there is no action. When a logout event arrives for a user, the runtime discards the partition and stops counting for that user. Since there is no output when terminating, the statement outputs counts every time a page hit event arrives. The filter condition for counting page hit events is this expression. ... From page hit. Parenthesis. User ID equals context.login.user ID. This filter condition makes sure that the partition only processes page hit events for the same user as the login event user. Without the expression user ID equals context.login.user ID, each partition would process each page hit event and thus every page hit event would be counted for every user. The termination condition for the context is this expression. ... Terminated by logout. Parenthesis. User ID equals login.user ID. This terminating condition terminates only the partition for the same user as the login event user. Without the expression user ID equals login.user ID, all partitions terminate when a logout event arrives.